Okay, so let's get into it. There's this quiet revolution happening right now. It's not out on the streets, but deep inside the walls of our buildings. And it's a story about water, about waste, and some seriously smart technology. We're talking about an AI-powered upgrade to one of the oldest systems we have, plumbing.
It all kicks off with a phone call. The kind of call every single facilities manager absolutely dreads. It's 5:30 in the morning in Melbourne, and that's the message they get. A single burst pipe has been gushing water for over 12 hours, totally unchecked.
And that one single disastrous phone call? Well, it adds up to this. $180,000 in damage. From just one pipe. In one night. I mean, that is just a staggering cost for what seems like a simple little failure.
But here's the thing, and this is what really gets me, the truly bitter irony of it all. The building already had advanced sensors. They could have prevented the whole mess. The problem wasn't a lack of tech, it was a lack of intelligence. The data was there, but no one and no thing was actually paying attention.
So in this explainer, we're going to break down how this is all changing. We'll start with what we're calling the invisible emergency hiding in our walls. Then we'll dive into the AI revolution that's fixing it, see exactly how this smart tech works, look at some pretty incredible real-world results, and then we'll peek into the future of water management.
All right, first up, let's talk about the sheer scale of the problem. This isn't just about the occasional big flood. We're talking about a constant, invisible crisis that's happening every single day.
Just look at this number, 30 to 40%. For the average commercial building in Australia, that's the percentage of water that just gets wasted. Think about that for a second. For every 10 liters of water they pay for, up to 4 of them are just vanishing through tiny leaks or inefficient systems. It's a shocking amount of waste, and it's happening right under our noses.
And when you zoom out and scale that waste up across the entire country, the cost is, well, it's astronomical. Over $3 billion a year. That's not just a number, that's real money that could be going into growth or innovation. But instead, it's just flowing silently down the drain.
But the cost of the wasted water? That's only part of the story. The real damage, the catastrophic floods like the one we started with, that adds another $8.5 billion to the bill every year. So when you put it all together, it's obvious. The problem isn't just about saving water, it's about preventing billions in damages that we now have the tech to stop.
And that brings us to the solution. We're seeing this fundamental shift in how we manage water. We're moving away from just reacting to disasters, and instead, we're starting to intelligently predict and prevent them. This, right here, is the AI plumbing revolution.
So, what do we actually mean by AI-powered plumbing? Well, it's not about just slapping more sensors on old pipes. No, this is an intelligent system that analyzes thousands of data points every single hour. It literally learns a building's unique water heartbeat, the normal rhythm of its flow, so it can instantly spot when something is just a little bit off, long before it turns into a crisis.
And the impact of this shift? It's huge. We're seeing buildings cut their water use by nearly half. But the real story is in the risk reduction. Leaks are found 85% faster. And the big one, those catastrophic, business-stopping disasters, they're reduced by 90%. This isn't just about being efficient. It's about having total operational peace of mind.
Okay, so how does it actually work? It might sound really complex, but it actually boils down to a few key pieces of technology working together. Let's open up the AI toolkit. Think of it like a team of digital detectives on a case. First, you've got your flow meters, and they track every single liter of water with ultrasonic precision. Then, you have pressure sensors that are basically checking the system's pulse for any weird changes. My favorite part is the acoustic detectors. They're like these tiny microphones that literally listen for the high-frequency hiss of a hidden leak. All that evidence then flows to the brain of the operation, the AI platform, which pieces all the clues together to predict trouble way before it starts.
And here is the absolute game changer. By analyzing all that data, the pressure, the sound, the flow, the AI can often give a facility manager 2 to 4 weeks of advance notice. That's not just leak detection. That's disaster prevention. It's the difference between scheduling a simple repair and getting that 5:30 a.m. emergency call.
Now, this all sounds great in theory, but what about in the real world? Let's look at some solid examples. The proof, as they say, is in the pipes.
Okay, take the Barangaroo South development in Sydney. It's one of the most advanced setups in the country. With over 2,000 sensors, they've cut their water use by almost half, saving $340,000 a year. But look at that last stat.
0 water emergencies in a year and a half. That is just operational excellence.
Or check out this powerful before and after from a medical center in Melbourne. Before they had AI, they suffered 3 major plumbing failures in just 18 months. After they put in a smart system, 0 unplanned shutdowns and 2/3 fewer service calls. I mean, for a hospital, that kind of reliability is absolutely priceless.
And hey, this isn't just for massive new skyscrapers. Here's the business case for a typical mid-sized building. So while the initial investment might seem like a lot, the annual savings mean the system often pays for itself in just over a year, maybe 2. After that, it's pure savings and way less risk. From a financial perspective, it becomes a really clear decision.
So, this technology is already transforming things, but it's not standing still. This AI revolution is really just the beginning. So, let's take a look at where this is all heading.
So our journey has taken us from just reacting to problems to now predicting them with AI. So what's next? Well, pretty soon we'll have what are called digital twins, perfect virtual copies of a building's entire water system. We'll be able to simulate floods or test upgrades without ever touching a real pipe. And even further down the line, imagine nanotechnology sensors flowing through the pipes, detecting corrosion at a molecular level, preventing failures years in advance.
You know, when it comes down to it, what's happening in our pipes connects to a much bigger picture. This isn't just about preventing leaks or cutting a utility bill. It's about creating smarter, more resilient, and much more sustainable buildings. It's a key piece of the puzzle for building the actual cities of the future.
So, really, we're left with a pretty simple question. In an age where our phones and our cars and our homes are all getting smarter, isn't it time our building's most essential systems caught up? The technology to prevent the next big disaster, it's not science fiction anymore. It's already here, waiting inside the walls.